It's a message from Mr. Paul.
New Jersey,
To y'all worldwide.
all around the world. And now, it's Newton's laws of. It's Newton's laws of. Newton's laws of. It's Newton's laws of.
In reality, we would not be here without the three laws of motion. Although we do see the three laws of motion in retrospect, we do not know how important the three laws of motion are. If there were three laws of motion, we were never here, we would not exist. But how can everyone in this room define the three laws of motion? Does everyone know the importance of inertia, force, mass, acceleration, and motion? Well, let's take it way back. The three laws of motion were discovered by Sir Isaac Newton on the 5th of July 1678. On that day, the three laws of motion were discovered. Each law gives a thesis on how movement and force works when implied in life. So let's take a look at the first law, also known as inertia. The law is defined as a body remains at rest or in motion without constant velocity unless acted upon by an external force. So let's break that down. The law of inertia defines that an object, whether it be a couch or a car or a human being, remain without movement unless acted upon by an extensive amount of force from another object. That would move.
Pretty sure that's not related.
But you may be thinking, how does this law affect me? Well, let's take Bruce on the table here. The table is represented as a motionless object, and Bruce is represented as a moving force. Bruce uses his force to the table forward, with the amount of velocity used allows for the table to move. But if you're playing a ball sport, once you kick a ball, you act as an external force, and the ball is the object. Once the ball reaches your foot, that is the external force. It is known as a kick, but the power carries the ball throughout its duration in the air. It is known as velocity that carries the ball and takes the power given to the kick taker. Now let's take a look at Newton's second law of motion, also known as the law of acceleration. Newton defines Newton's second law as a force acts upon an object. It will cause the object to accelerate. The larger the mass of the object, the greater force will be to cause it to accelerate. Now let's break that down. It is defined as when an object moving or a mobile object, by adding extra force, will allow the object to move at a faster rate. When you're playing footy, you release the ball to another player with your hands. It's known as a pass. Pass passes are the ones that go for 30 meters that are strong and powerful and hit the player right on the chest. When you pass a football, the more effort you put into the pass, the better the pass will be. If you were to pass a beach ball or a medicine ball, the ball would not go as fast or as long due to the weight of the objects holding the ball down. In reality, Newton's second law of motion can be found in any track of movement. Whether you're walking through a park, talking to a mate, or drinking from a water bottle are all examples of Newton's second law of motion. Even when you think you are using Newton's second law of motion, the harder you study, the harder you concentrate, or the think faster will make your neurons in the brain go quicker. But what about the final law of motion, the third law of motion? Well, just like the other two laws, Newton had given it a special name. It's known as the law of reciprocal action. And the law is defined that in as many action there is an equal or opposite reaction. Now let's break that down. We can define this law as being for every force there will be an opposite force of greater or equal ability but goes in the opposite direction. But how does this work in reality? Well, let's take rugby league, or gridiron, or union, AFL, or just any contact sport. When the ball carrier moves with the ball, he is creating a force so powerful and so strong, it can only be stopped by another person of equal and greater force. Moving in another direction, this opposite force we know as a defender or tackler, who uses the ball force to create the move back the ball carrier's force. But you may be thinking, that's in sport. How does this law of motion apply to me in an everyday situation? Well, much like Newton's second law of motion, a lot of movement and physical activity you do, such as walking or jumping, all apply in the third law of motion. When you jump, you will exert a force on the ground, and the ground will exert a force back on you, which will cause you to move upwards. Newton's law of motions make us who we are today. If we didn't have these laws of motion, we couldn't fly a man to the moon, or play sports, or how would coaches understand how to create tactics with the laws of motion? But could we even exist as friction kept us down on Earth, and live in the laws of motion if they were not in place? Newton's law of motions are important and the fundamentals they need to be studied for many years to come. So after watching this video, we hope you understand further the laws of the motion for a long time, and not just to pass an exam. Thank you for watching.